Alrighty, here we go, our fifth and final example for this lesson. Alright, so we now have an integral where we have multiple exponentials, both the numerator and denominator have an e involved, but both of them are binomial, so one of them is not longer than the other. So because one isn't longer than the other, when I'm choosing something for u, I want to go with the one that has a higher degree involved. So looking at the binomial pieces, looking at the polynomial part, not the exponential part, I've got a 2 on the top and a 2x on the bottom. So 2x is a higher degree, so u should be the one with the 2x, okay? So we're going to do u is equal to the denominator expression. And I'll be honest, many times it ends up being the denominator expression instead of the numerator, but again, first you look for which one is longer, and then secondarily you'll look for which one has a higher degree, and that's what you choose for u. All right, now derivative of this, the derivative of 2x is just 2. The derivative of e to the negative x, okay, so we're doing the derivative of e to the negative x. I'm just going to write out where it's coming from. So the derivative of an exponential is itself times the derivative of the exponent. The derivative of negative x is negative 1. So this is going to become negative e to the negative x, okay? So the derivative of e to the negative x is negative e to the negative x. That binomial gets multiplied by dx. Now doesn't that work out nicely? Because look at the numerator, and what do you see? The numerator in the original problem is exactly the same as our du. So this part gets replaced by the du, and this part gets replaced by the u. So when I go to rewrite this integral, I'm going to have an integral sign. This is gone, so there's a du at the end. I've got a u in the denominator. There was nothing else left, so it's 1 over u du. And we've seen this a few times now in this lesson and others. The antiderivative of 1 over u du is the natural log of the absolute value of u plus c, because we don't have any bounds to plug in. Okay. So final answer for this one will be the natural log of the absolute value of 2x plus e to the negative x plus c. Okay. We are going to do a follow-up though, because they won't all become 1 over u du. Okay, so we're going to do a quick follow-up, and then we are done with this lesson. Okay, so what if it was this instead? Antiderivative. The top is still 2 minus e to the negative x. The denominator, though, is parentheses cubed. Sorry, parentheses cubed. And I have in the parentheses 2x plus e to the negative x. Okay, sorry, that got a little messy, but parentheses cubed around the denominator. So what's going to happen there? Okay, well, we'll still choose the same thing for u, and now it's even more clear that it should be our u because it's inside of parentheses cubed. And remember, when we first started doing u substitution, u was always whatever the inside function was, which thing is inside of something else. So this will still have the same u and the same du. So it's still, I'm just going to write same u and du as over there, okay? So it's still this and this. That just means that this right here will be u, that top part will be our du. So when we go to do our rewrite, we're going to have u to the third in the denominator instead. That's the difference. The only difference between this start and this start was the parentheses cubed in the denominator. So how do I find the antiderivative of 1 over u cubed? This is not a natural log antiderivative, okay? This we can rewrite as u to the negative third power and do the power rule. So sometimes you're going to have power rule involved and you need to be watching out for that. It's not automatically a natural log if there's a variable in the denominator. It's only when it's 1 over u or 1 over x. As soon as there's another exponent involved, it's going to revert to negative exponents and power rule, okay? So the power rule says add 1 to the exponent, which is negative 2, divide by the new exponent, put on your plus c. Now we know we can't leave a negative exponent on a polynomial term, So I'm going to rewrite this. There's a negative 2 in the denominator. Now the u squared will go in the denominator. We have the plus c. There's nothing left up top, so it'll be 1 over. If you prefer, you can put the negative with the 1. It really doesn't matter as long as the overall fraction comes out negative. So this final answer will be, I'm going to write it as just a negative out in front, 1 over 2 u squared plus c. And I need to fill in what the u was. And the u was the 2x plus e to the negative x. I know that's super teeny tiny and probably hard to see, but it's the u that we chose on the beginning. It's what's written inside the parentheses cubed, okay? So the final answer here would be negative 1 over 2x plus e to the negative x squared plus c. Totally different answers, okay? So you need to be watching out for those little details, those little differences. But this is our 5th and final example for this lesson. Good luck with your homework, guys.